Yes, today's class we will go for large integer multiplication using divide and conquer method. So before understanding large integer multiplication, let us know how much time it consumes to perform multiplication according to the school level. So for example, I have one integer number x and y. These are two integer numbers and for example which contain four digit number. For example 4, 3, 2, 1, and another integer 1, 2, 3, 4. So these two integers are there. When I perform addition on these two, so 1 plus 2 5. So here I have performed one addition operation, so which consumes 1 unit of time. Okay. So similarly, 2 plus 3, which is 5, which is also taking 1 unit of time. 3 plus 2, it is also 5, which consumes 1 unit of time. 4 plus 1, which is also 5, which is also consume 1 unit of time. So total, this addition is taking 4 units of time to perform this operation by the computer. So when it is 4 digits, which is taking 4 units of time. If in case this one is n digit number, I am writing this one as A0, A1, A2, and so on, AN digit or AN minus 1. AN minus 1 is nothing but total n digit number because I have started it with the A0. Similarly, I am taking Y value which is also having n digit number b2 and so on bn minus 1, so which is going to take n additions. So this addition is completing in order of n time. Okay. Similarly, if you go for subtraction also perform same. So which is also going to take order of n times. This is same for addition and this is same for subtraction. Okay. There is no any difference to find the addition and subtraction. It will take order of n. But when I go for multiplication, understand how much time it consumes. So the same four digits number I am taking, which is 1, 2, 3, 4, and y is another integer, which is 4, 3, 2, 1. So when I go for this, how this is evaluated? This only one integer number 1, which is multiplying with first 4 comma 3 comma 2 comma 1. These four individual digits are multiplied with 1. So you will get one value. It doesn't matter what value it is returning. Let us understand how many multiplications will be performed on this. We will consider. So here one digit multiplied with a 4 digit number, so that which is going to take 4 units of time. Similarly, 2 is also multiplying with this 4 digit number. So which is also take 4 units of time. And 3 is another integer which is also multiplying with same integer 4 units of time. And 4, another integer which is multiplying with 4 numbers, which is also taking 4 units of time. So total which is taking 16 units of time. So if you understand the relation between this number of digits and the number how many times it is calculated. So if I understand the relation of this total number of units and number of digits, so this is equal to 4 into 4, where 4 is the number of digits, 4 is the multiplications. So total 4 square number of multiplications has done. Along with that, what are the numbers it has generated? On top of this, we are performing addition operation. So four different numbers we get, so that we need to perform four additions. Okay. So this much times it has taken on this number. Similarly, in place of this, I am going to write like a expression. So this is the toppest digit, like 1, n minus 1, a n minus 2, and so on, a3, a2, a1. So b n minus 1, b n minus 2, and so on, b3, b2, b1 not. This is a naught. When I perform multiplication on this, by understanding this time, we need to calculate how much time it consumes. So here n digit number and each digit multiply with another n digit number. So total which is taking n square multiplications along with the n additions. Okay. So if I go for multiplication of two numbers, which is going to take, I am going to represent this one as T of n, where n indicates number of digits. Okay. So number of digits is equal to n square plus n. But while calculating the time complexity, I am going to take only highest degree of this expression. So T of n equals to n square is the highest degree. Order of n square I am taking. So here to perform multiplication operation, total how much time it is consuming? Order of n square. This much time our regular full method it is taking. But when you go for divide and conquer approach, we can compute the multiplication of two integers number better than this order of n square time. Okay. So let us know. I'm going to represent this one on a graph. So here, this is the y-axis and this is x-axis. Okay. And I am going to take the values here. This is one input. I am going to take this one as a number of inputs. And the y-axis, which is taking the time to be complete on this input size. So this is one element when I have given two element, three element, four element, five element. So like that, I am taking the number of inputs. When I take 1 unit of time, how much time it has taken, I am going to calculate. This is 2, this is 3, this is 4, this is 5, this is 6. So I am going to denote this one. 1, 2, 3, 4, 5. So here n square. So here I am going to draw one line. So this is when it takes one digit, it is taking 1 unit of time. When it is two digit, 2 units of time. When it is three digit, 3 units of time. The growth is going like this. Okay. So this is represented by order of. May I know which one is performing order of n? So subtraction is performing order of n and addition also performing in the time of order of n. But when I go for multiplication, how it is executing? When it is 1, whose time complexity is 1 only, 1 square. When it is 2, its time complexity is 2 square, is nothing but 4. When inputs are 3, time complexity is 3 square, which is equivalent to 9. Okay, so the growth is evaluating like this. I am going to draw this one with the other color. So the growth of n square is like this. Okay, so like this it is going exactly. I didn't draw. So this is order of n square line. So here, when you go for divide and conquer method, I am going to reduce the time complexity. Observe here, instead of executing any program in order of n square, if I compute this one in order of n, we got more success in developing a good algorithm. But exactly, I am not giving promise that I am not converting matrix multiplication of large integer number directly in order of n. I am going to evaluate this one better than n square time, but worst than order of n. So this is going to achieve large integer number when you go for divide and conquer method. So let us see what time it consumes when you go for divide and conquer method, and I will show proof whether it is reducing or not. Is this clear? So let us go for how to compute large integer multiplication using divide and conquer approach. So here, now I am taking one numeric integer value which is capital N, which is capital B. So this capital A is A of n minus 1 digit, A of n minus 2 digit, like this, A of n digit, A of 0, A naught. Similarly, B n minus 1, B n minus 2, and so on, B naught. Okay. So like that, I have taken one integer number and I am going to perform multiplication. So instead of performing multiplication on this size of number, I am going to rewrite this one into two sub-equations. Let us see how I am going to write. Capital A, I am rewriting this number as A1 into 10 to the power of n by 2 plus A naught. So B, I am going to write as B1 into 10 to the power of n by 2 plus B naught. Like that, I am going to divide this entire digit number into two equal sizes. So I am going to show whether this equation working fine or not. So for example, I am taking a number. A number is 1, 2, 3, 4. So here n is nothing but number of digits. So total how many digits it has? 4. So whose value equal n value equal to 4. So when I divide this one, I am going to divide this one exactly to equal parts. So 12 into 10 to the power of 12 is nothing but A1 and 3, 4 is nothing but A naught. 12 into 10 to the power of 4 by 2 plus A naught. So 12 into 2 1 ja 2 2 ja 10 square, which is equivalent to 100 plus A naught. A naught is nothing but 3 4, means 34. So 1200 plus 34, 1234. So did I get the original value or not? So similarly, this is the way I am going to divide capital A is one integer number into two equal parts. This is exact division. So you may ask, sir, you have taken 4-digit number, so exactly it has divided. What if when I go for 3-digit number, 531? So when you go for divide and conquer method while performing large integer multiplication, better to make this one as a even integer size. So here, how do you make? By concatenating zero value left side to this one. So 0531, which is also equivalent to 4-digit number, and the magnitude value cannot be changed. So even you write 0531, its value 531 only. If you do not write zero prefix of that one, its value 531 only. So better to make like this and compute that one. But as of now, I am going to consider this size is even size. I have distributed this one like this. Okay. Next, on top of this, I am going to perform multiplication. So let us see how I am doing. So A1 10 to the power of n by 2. Next, A naught. B1 10 to the power of n by 2. B naught. These are the 2-digit numbers I am going to consider. So here don't confuse by writing 10 to the power of n by 2, which conveys that in which place this A1 need to be right. Okay. So if I do not write 10 to the power of n by 2, which is to be considered? For example, if it is units place, it is tens place. The tens place is represented by this equation. Okay. So don't consider I am also need to perform this value means no need. Okay. Next, I am going to perform multiplication operation on this one. So A naught into B naught. Next, B naught is multiplied with this A1. So A1, I am writing B naught, and I am going to give the position like a 10 to the power of n by 2. So this B naught has multiplied with these 2 digits, and now I am going to multiply this B1 with these 2-digit number. So A naught B1 10 to the power of n by 2. This is completed. Now I will multiply these two. So A1 B1 10 to the power of n by 2, 10 to the power of n by 2. Two times I have 10 to the power of n by 2. 10 to the power of n by 2 into 10 to the power of n by 2. So now I need to perform summation operation on these terms. So how it will be performed? First one, this is A naught, B naught. Next, if I write plus between these two, I need to perform addition operation on these two. So when I do plus operation, A1, B naught, A naught, B1, and I am going to write this term as a common term. So 10 to the power of n by 2 plus into A1, B naught plus A naught, B1. Next, this term A1, B1 into, if I observe this one clearly, a to the power, let us consider this is look like a to the power of n into a to the power of n. When bases are same, you need to perform addition operation on the powers. So n plus n, which is equivalent to a to the power of 2n. So this is the way I am going to calculate. So similarly, 10 to the power of n by 2, 10 to the power of n by 2. What is the result? A to the power of n by 2 plus n by 2. So 2n by 2. So 2 cancel, I will get 10 to the power of n by 2. So after that, I am going to perform addition on these three terms. So how our equation has modified? Example. This total result is capital C. C, I am going to rewrite it as A1 B1 into 10 to the power of n plus A1 B naught plus A naught B1 multiplied with 10 to the power of n by 2 plus A naught B naught. This is the way you need to perform large integer multiplication, which is going to reduce the time. But if you observe from this also, we can reduce the time complex. So how I will do? So again, I will show the whether this time has reduced or not. So I am giving another new labels to these terms. So this is going to be represented by C naught. This entire time I am representing this one as C1. This entire time I am representing it as C2. So the total result is C equal to C2 into 10 to the power of n plus C1 into 10 to the power of n by 2 plus C naught. So this is the equation. Now if you observe here carefully, how many multiplications we are performing? This is one multiplication. Here two multiplication. Here three multiplication. Here four multiplication. So to perform this operation, I am doing four multiplications along with that plus 1, 2. Two additions. Two addition operation. So here already I said multiplication is taking order of n square times. Addition is taking order of n. So if I reduce one multiplication from this one, which means did I improve the performance or reduce the performance? Obviously, performance of this multiplication definitely increases when I reduce the number of multiplication. So this same equation I am going to rewrite with three multiplications plus two additions and plus two subtractions. Like that, I am going to convert. So let us know how this is going to be performed by using new equation. I will tell you. So that new equation, before writing the new equation, let us understand one more term. So we calculated C0, C1, C2. Other than that, I am going to write another equation which is C3. So let us understand how I am going to write. So A1 plus A0, B1 plus B0 minus C1 minus C2 minus C0. This is the new expression I am writing to reduce the number of multiplication. So I am going to evaluate this one. Let us understand what do we get. This is the distributive law I will apply. A1 B1, A1 B1 plus A1 B0. Next A0 B1, A0 B1 plus A0 B0, A0 B0. Did I compute this C2 value earlier? Yes. What is the C2 value? A1 B1. A1 B1. What is the C0 value? C0 is already calculated, which is A0 B0. So A0 B0. Next, what I am doing? I am going to subtract this one. So A1 B1, A1 B1. I am going to cut these two terms. Next, A0 B0, A0 B0. I am going to cross these two. So what is the result I get? A1 B0, A0 B1. So A1 B0, A0 B1. So did I get the same result or not? But if you observe this equation, how many multiplication I am doing? Only one multiplication. But how many additions extra I have written? 1, 2 total. Okay. So here 4 additions, 2 subtractions. So this is the way you have converted. 1, 2 and 3, 4. So which is also take n units of time. So there is no any difference you get. But what did you observe? N square I have converted to n. How many n's? 2 n's. So if I observe these two this one is better than this one. Okay, let us know how it is calculated. So how I am going to rewrite this expression, you understand. So capital C equal to, I won't change any C2 into 10 to the power of n by 2 plus C1. So I am going to replace this C1 with this C3. So C3 10 to the power of n by 2 plus C0. This is the equation to perform large integer multiplication. Okay. Now we need I need to prove how much time this large integer multiplications will take. Now I am going to find the time complexity. Time complexity of large integer multiplications. What is the equation just now I have written? Capital C equal to C naught plus C3 into 10 to the power of n by 2 plus C naught C1 C2 into 10 to the power of n. This is the equation. How many multiplications C1 is doing? Now you understand. We will concentrate on multiplications only. This is one multiplication. This is another multiplication. This is another multiplication. And how many digit numbers multiplying? N by 2 digit, because actually n digit number I have equally divided that one. So two n by 2 integer numbers are multiplied. That you need to remember. So T of n, which is nothing but time taken to perform on n digit multiplication, large integer multiplication. How I am going to write? I have divided this n into T of n by 2. On this n by 2, how many multiplications I am performing? 3 multiplications. So 3 into T of n by 2 plus how many digits when I multiply this one? Total n digits you will get. So total n number of additions you are performing. N additions. Okay. So this is the way I have written equation for time consuming to perform large integer multiplication. I am going to represent this one with the one equation. Now I will go for substitution method to find how much time these large integer multiplications will take. Next one. But from this expression, do we know how much time it will take to compute T of n by 2? We don't know. Again, I need to find what is the time this n by 2 will take. So I am going to write another expression, which is 3 multiplications on T of n by 2 is the actual size, again, which is also subdivided. So when I write n, we get n by 2. So when it is n by 2, we will get n by 2 by 2 plus n by 2 comparisons, additions. This is equation 2. Now I got T of n by 2 value. Again, I am going to substitute this value inside this main equation. So the resultant of T of n is equals to this 3 into This entire time I'm writing at here. 3 into T of n by 2 by 2. So I am going to write this one is 2 into 2. 2 into 2 equal to 2 square plus this n by 2 plus the original n value. This is n. I am rewriting this equation. 3 into 3, 3 square into T of n by 2 square plus 3 into n by 2, 3 into n by 2 plus this original n value. This is equation 3 and I am going to represent this one with T of n. Now, again we have one more problem. What is that? Do we know T of n by 2 square value? I don't know. So for actually I can write directly equation, but for understanding purpose, again I am re-evaluating its value. So T of n by 2 square is equals to 3 into T of n by 2 square whole by 2 plus n by 2 square. This is the equation we get for T of n by 2 square. I am going to give equation number as 4. Now, we substitute this 4 equation in equation 3. Substitute equation 4 in equation 3. So let us know what is the value we get. So time taken to perform on n-digit multiplication is equals to this 3 square I am writing, and in place of T of n by 2 square I am substituting this entire equation. So 3 into T of n by 2 square into 2. So n by 2 cube plus, so this n by 2 square followed by 3n by 2 plus this n. Now again I am performing distribution. 3 square into 3. 3 to the power of 3 into t to the power of n by 2 cube plus 3 square into n by 2 square. So you observe here carefully how I am going to rewrite. 3 square by 2 square. So instead of that 3 by 2 whole square I am writing into this n value plus this, observe here 3n by 2 I am writing 3 by 2 into n plus this as it is n I am writing. So this is for T of n. Now like this, how many times I need to pump? Okay, again I don't know this value. Again I don't know another number. So instead of rewriting this one, so I am going to divide this term into k times. K times. After k times, this equation is converted as T of n equals to 3. After 3 terms, this will become 3 to the power of 3. I am going to write this one as a 3 to the power of k, and time computing for n by 2 to the power of k divisions plus. So when it is first equation, you got only one n. When it is substituted, you got 3n by 2 plus n. When you substitute third time, 3 by 2 whole square into n, 3 by 2 into n, next n. If I do this one k times, this will become, observe here carefully, 3 by 2 k minus 1 time. Why k minus 1? When you get 3 at here, you got 2. When you get k at here, you will get k minus 1 into n plus 3 by 2 whole to the power of k minus 2 into n plus 3 by 2 k to the power 3 by 2 to the power of k minus 3 into n plus and so on. You will get 3 by 2 plus 3 by 2 into n plus n. Okay, so this is the equation you get. So this is for finding the time taken for t of n. Now you observe here carefully. So from these all terms, we have one common term which is n. I am going to write this one separately. So t of n is equals to 3 to the power of k into t of n by 2 to the power of k plus from these all terms I am going to write n as separately. So again I am writing this one in reverse order. So when I take n common from this one, I will get only 1. Plus from this, I will get 3 by 2. From the next term, I will get 3 by 2 whole square. So if I write like this, 3 by 2 whole to the power of k minus 2 plus 3 by 2 whole to the power of k minus 1. So this is the term we will get. This one is the last term. So this is the way we have converted. Next. Now, if you go for this equation which has two terms. So first term is this one and second term is this entire thing. If you observe this equation carefully, which is look like a geometric progression equation. So what is the GP? How it looks like? A, AR, AR square plus AR cube plus and so on plus a r to the power of n minus 1. This is the equation. So how do you find sum of this one? When I compare these two, a is nothing but 1. Next, in place of r, you have 3 by 2. Is this clear? Now, how can I find sum of this entire thing? We have one predefined formula to find the sum of this one is a into r to the power of n minus 1 by r minus 1. This is the equation. Or you have another equation that is a into 1 minus r to the power of n by 1 minus r. You can go for any one. Very simple. I have taken minus as a common. So these two terms as interchange. Minus minus will be cancelled so that you will get this one. So generally we will convert this one for getting positive and negative value. For example, r power n is greater than 1. Then you can go for this equation. If r power n is less than to 1, you can go for this equation. Okay. So this is for simply remembering. But ignore this one. I am going to take this one. So if I substitute these values in this, let us know how it will be converted. A value 1, 1 into, what is the R value? 3 by 2. 3 by 2. So in here you have n, but in top, in our equation, we have k minus 1. So n minus 1, k minus 1. What can I write? Here, I am going to write k. K minus 1. This entire term I am going to write in the parenthesis whole by r is 3 by 2 minus 1. So if I substitute this equation, so 3 by 2 whole to the power of k minus 1 by. So here I am going to take this one as a LCM 2. So LCM is 2. 3 minus 1 1 ja 2. So 2 1 ja 2. So this one will be converted as 3 by 2 whole to the power of k minus 1 whole into 2. This is the term value only within this bracket. Along with that, we have n. Now I am going to substitute this value at this place. So let us know how it will be converted. So T of n equals to T of n equal to 3 to the power of k into T of, what is the value here? Mm, n by 2 to the power of k. So n by the power of k plus n into this equation 2 into 3 by 2 whole to the power of k minus 1, right? So here which one we need to learn? We know what is n. We know these are the 3, these are the 2, these are the fixed constants. So here when do you get this equation? After k divisions. So I need to know what is k value. If I know k value, I can tell you what is the time complexity to perform multiplication on n digit number. So how can I compute this one? From this equation, you take only n by 2 to the power of k value. Okay. So n by 2 to the power of k, I am saying which is 1. Why it is 1? So here after k divisions, so for example, 1, 2, 3, 4, 5, 6, like that I have written. First division, next division, next division. Like that, if you perform division operation, at last you will get only one digit number. Am I right? Or? And what I am writing in this one? Number of digits. So n by 2 to the power of k will become k after k divisions. Okay. So that's why I have written like this. So what is n value? 2 to the power of k value. But which one you need to find? K value I need to find. So that I am going to apply log value both sides. So log n equals to log 2 to the power of k. Now, how can I rewrite this one? I am interchanging these two equations. So log e to the power of n equal to n log a. So k into log 2 equal to log n. Next, k equal to log n by log 2. Now I found k value. Now I need to substitute this k value in our main equation. So I am going to give this equation number as, what was the last equation number? 4. I am giving its equation number as 5. So this is 5. Substitute k value in equation 5. So how it will be converted? T of n equals to mm, 3 to the power of k value log n by n. So if I convert this equation, log a by b equal to log n base 2. So log n base 2. So t of 1 plus this entire term, how it looks, 2 into n. 2n into 3 by 2 whole to the power of k value. What is the k value? Log n base 2 minus n into 1 n. Okay. So this is the way I have converted equation. Now t of n equals to, so time taken for multiplication of one digit number, how much time it takes? Only 1 unit. So this entire value will become 1. So 3 into log, sorry, it's not into, 3 to the power of log n base 2 plus 2n into 3 by 2 whole to the power of log n base 2 minus n. Now, when you have equation like this, we need to make power as a known constant and base as a n or a constant. It's not constant, like variables. So how can we interchange this one? We have again logarithmic equation. So log a to the power of log base b t equals to, this value equal to c to the power of log a base b, which means log value is replaced with its base integer value. Okay, just you interchange these two terms. So how it will be converted? This n will come down. So n to the power of log 3 base 2 plus 2 into n into this n will come down. N to the power of log 3 by 2 base 2 minus n. Now a to the power of m into a to the power of n. So how it will be converted? N into log 3 plus 2 into a to the power of m into a to the power of n. A to the power of m plus n means log 3 by 2 base 2 plus 1 minus plus n. This is plus n. Is it plus n or minus n? It's minus n only. Minus n. If you observe this entire thing properly, so we need to take the power whose power is more, that I need to take. Okay. So this is total time it will take, T of n by 2. Now, the total time which is consumed for large integer multiplication is equals to, which is having more power? This is having the more power. Okay, highest degree. So n to the power of log 3 base 2. This is the time which consumes. And I am going to take worst case, so I am going to represent which as a order of n to the power of log 3 base 2. This is the time which it takes to compute large integer multiplications. Now let us calculate what is the time, what is the value of this one, log 3 base 2. So I am going to calculate this one from online. Is the value of log 3 base 2. So whose value it has not given calculator. So when I see this, what is the value it has given? 1.5850. So this is equals to order of n to the power of 1.585. This is the value. What is the school level time complexity? Order of n square. Order of n square is better. Order of n to the power of 1.585 is better. N to the power of 585 is less than 2 order of n square. So, did I justify divide and conquer method has less time consumption when I compare with school method? Okay, so this is the way you need to find the large integer multiplication. So large integer multiplication I have given